Hi guys, welcome to my YouTube channel. So in this video, we're going to be looking at the basics of C. So if you're new to the channel, please don't forget to subscribe, like the video, as well as leave a comment so that I know what you guys think about the content. Now, what is C? Well, C is a procedural language, which means that it follows a procedure or set of commands that must be followed for smooth execution of the program. This means that one has to specify not only what to do, but also how to do it. C is good for resource optimization as the programs made using C do not take up much of computer memory space. C is a compiled language, which means that one has to compile the source code into executable code, which can then run as a process on a machine. So the compiler that we're going to be using is GCC. Now, your source code is the same program that you've written in your C file. So whatever code that you've written in your C file is your source code. Now, what are we going to look at in this video? We're going to look at what variables are in C, what data types are, how to comment in C and which type of commenting is better, how to declare a variable and initialize it, how to use putchar, puts, printf functions, as well as how to compile C files using GCC, the different flags one can pass to GCC. As an example, we have the capital letter S flag, which generates assembly code, and many other different flags that we have. And we're also going to look at what a script is, as well as how to compile a C file from a script. Now, what is a variable? Well, simply put, a variable is a name that's given to a memory location that can store data of a given, of a specific type. So we're going to look at the different types that we have in C in a few minutes from now. So a variable can also be used to store user input, perform calculations, as well as display output, and many other different things. So the value of this variable can change during execution of a program. So as an example, the variable myVar can initially hold the number or the value 1914. This is at the start of the program. So this is in memory, then this is the variable. So the variable, whenever you access this variable, you are indirectly accessing 1914. Now, during program execution, the value of myVar might change from 1914 to 20. So during execution of the program, when you now access myVar, it changes, it won't give you 1914, it will now give you 20. Now, what are some of the things to consider for variable names? Well, the name should begin with either a letter, $, or an underscore. It should not begin with a number, period, or dash. It should not be a reserved keyword. Now, every language, be it C or maybe if it's Java or if it's C++, all the different languages have got their own reserved keywords. So make sure that the variable name is not a keyword such as int, or maybe if it's break, if it's continue. Now, there are many more reserved keywords that you can find, so you can search for those bit on the internet. So the names are case sensitive, which means the name var, which starts with a small letter v, is not the same as the name var, which starts with a capital letter V. So let's say maybe you've declared the variable as var that has a small letter v. During execution of the program, if you try to access this variable using a capital letter V, it's going to bring about some errors because var starting with a small letter v is not the same as var starting with a capital letter V. These are different names. The name has to be descriptive. At least it should give a clue as to what the variable points to. As an example, when you see a name such as Sam, so the variable name Sam is kind of descriptive because you will know to say that this variable probably holds the sum of different integers or some numbers. Now, how do you declare a variable in C? So to declare a variable, you simply need to specify the data type, then the variable name. So as an example, it can be int, myVar. It can also be short, it can also be long, or any other data type. Now, what is a data type? Well, this tells the compiler what type some given data is, so that the compiler knows how to use as well as store the data. Now, why is this important? Well, this is important as different data have got different properties such as size, the range, and operations. So the data types in C are character, which is represented as CHAR. So the character data type is for data such as A or the letter N. Then you also have short, int, long. These are for integers like 4, 5, 7. Then you also have float, double, which are used for fractions. As an example, can be 4.5 or maybe 10.6 or maybe 1,000,000.7. So those are stored using float as well as double. Now, these data types have got different sizes. Now, what are some of these sizes? Well, for the data type int, it's usually 4 bytes. For the data type for characters, it's usually 1 byte. Short, 2 bytes. Long, usually 8 bytes. Then float, you have 4 bytes. Then for double, you have 8 bytes. I'm putting usually because depending on the architecture of your system, it might be different for your computer or your PC. For example, for int, instead of 4 bytes, you might find maybe it's 2 bytes on some architectures. So that's why I've put the word usually. Well, these are different. There are some that are signed, then some are unsigned. So whenever you declare a variable, just using the name or the word int, then you are using a signed data type. So it's signed int. So automatically when you just declare a variable as int, it's a signed int. Now, if you want it to be unsigned, you need to specify and say unsigned int. So you put unsigned before the word int. Now, what is the difference between unsigned and signed int? Well, the difference is that for signed variables, it can hold both negative as well as positive numbers. Now, for unsigned, it can only hold positive numbers. So don't get me wrong. So I'm saying for signed, it can hold both positive as well as negative numbers. Then for unsigned, it can only hold positive numbers. So we also have different format specifiers. So you have %d, you have %c, then you also have %hd, then you also have %ld, %f, then %lf. So these are the different format specifiers for these different data types. Now don't get confused about this. It's going to come in handy when we start looking at functions such as printf, which helps to print formatted output onto the console. So these are the format specifiers that we're going to be using. So you don't need to master all the different format specifiers. And these are not the only data types. You can search for more on the internet. And these are not the only format specifiers. So you can again search for those. So these are just some of the basic ones. And so you can do well to master maybe the one for int, which is %d, for character, %c, for float, which is %f, then for double, which is %lf. Now, for you to be a good programmer, it's important for you to know the sizes of these different data types, because it wouldn't make sense for you to declare a variable that's holding a number like 2 and declare it as long. For example, you say long, then maybe you declare a certain variable, then the variable only holds 2. The thing is that when you declare a variable as long, it means that your computer is going to reserve this amount of space in memory for that variable. So even if the number that's there is just 2, the computer has already reserved about 8 bytes for that number. Now this is wastage of space, and your programs are going to be big or large for nothing. So you need to make sure that you know these sizes so that whenever you want to declare a size, a number or a variable, you know to say that if I want a variable that holds maybe a smaller number, then I'm going to use short. If I want a variable that will hold a really large number, then I can use long. Now, what are the different flags that one can pass to the GCC compiler? So you can pass a capital letter E, which would tell the GCC compiler to preprocess the source code and output the preprocessed code to the console. And then you can also use a capital letter S, which will tell GCC to generate assembly code from the source code. C, which will tell GCC to compile the source code without linking. Then you also have O, which is used to specify the output file. Now, if you don't specify the output file, GCC will make a default executable output file for you. And the output file is a.out. So we're going to see that in a few minutes from now. You can also use this flag, which is wall. So it starts with capital letter W, so WALL. So this enables all warning messages. Then you also have this other one, which treats all warning messages as errors. Then you also have pedantic, which issues warnings for non-standard C code. So let's now get interactive and see how all this takes place on the console. So I'm using a console, but then for you guys who are maybe using an IDE, let's say maybe if it's CodeBlock or any other IDE, you can still follow along. So I'm just going to create a file. So I'm going to name my file main.c. Of course, the name can be any name. You can name your file anything that you want if it's your name or anything. So I'm going to name mine main.c. So the first line is include. So you include the libraries that you have. So in this case, since we are only looking at the input-output functions like scanf, printf, put, as well as putchar, the only library that I might need in this case is stdio.h. Then I'm going to say int main, then void, then I'm just going to say return 0. So for those of you guys who are using IDEs, this is probably what you find immediately you just open your C file. So this is what you're going to find. But then for those of you guys who are using the command line like me, you won't see anything, and so you need to declare these on your own. So first things first, how do you get to comment in C? So to write your comment, you first of all do a /. So after that, then you put this, then you can press enter, and then you can now describe what your program actually does. I'm going to just say main, then I'll say this is the start of my program. So this is describing main. Then you can also describe any other variables that may have been passed to the function, but then we'll come to those things later in the tutorial. So this is how you get to comment. So you open, then 2 stars, then you now make your comment. So main, this is the start of my program. Then you close the comment. There's also another way of commenting, of course, which is where you just use these two /. Now this is not advised in most cases. Even Betty is going to show errors if you are to use this, because this is not supported on all different types of architectures. There are some that might take these as being errors. So it's good conversion for you to just use this. So just stick to this, especially if you're an ALX student and you are going to have Betty that's going to be checking your code syntax. And so if you use these, it's going to show errors. So just stick to using these. So even for this, I can actually say this is a comment and it's going to be treated as a comment. But then we are not going to be using this. And so we'll just stick to this way of commenting. Now, how do you get to use the function putchar? And how do you also get to declare a variable? So to declare a variable, just as we did earlier, so you can simply say int, then you simply say my var. So we have now declared a variable. So if we want, we can initialize a variable. So by initializing, we mean you let the variable point to a certain value. So that's how you initialize a variable. So if we want, we can just initialize it from here, and we can say that my var is equal to maybe a number like 78. Or if you want, you can first of all declare the variable, then you initialize it later on and say my var is equal to 98. So if you want, you can do this, but then I don't like doing that. I'll just say int my var is equal to 98, then I'll close it. Then how do you get to use the putchar function? So putchar is used to print a single character onto the console. So let me just comment it out because I'm not going to use it for now. So putchar is used to print a single character onto the console. So you can say putchar, then you now specify the character. So let's say maybe I just want to print the character C. So this is how you can use putchar. So you only specify one single character. If you give putchar more than one single character as arguments, it's going to bring errors. So you can now also specify to say that you want a new line after this. So again, you can specify that character and say you want a new line. So you want putchar, you print a letter C, then you also specify that you want a new line. So now let's just escape. So we'll save this, then see how we can now compile our file using GCC. So this is our file. So if you want to use GCC, you simply say GCC then main.c. Now I haven't specified an output file. If I wanted to specify an output file, I would have done this. Then maybe I just say main. Then this is where we have specified an output file. So if I was to press enter, if I press enter then do ls, we'll see that main is now there as an executable. So if I run this executable file, which is main, it's going to print C followed by a new line. So whenever you see a file that's in green, then just know that this is an executable. Another way of checking, you can just say file then main, and it will show you to say that this is an executable. So it will show you that it's an executable. So now what if we didn't specify the output file? What if we just say gcc main.c? So this is going to create the a.out file that I was talking about. So this is a default file that will be created whenever you use GCC without specifying the output file. So if I was to run this a.out, it will again print C followed by a new line character. So it will still do the same thing. So the new line character that I'm talking about is this one. So it's not going to be printed onto the console. It just prints another line. So let's now see what would have happened if we didn't put this new line character. So let me go back to my code. Then let me not put this. So I'm going to remove the new line character. So I'm just going to comment it out. So I'm going to do that. And then we'll see what's going to happen when we don't specify the new line character. I haven't specified the output file, and so the output file is still the same default file, which is a.out. So I'm going to say this, that a.out, and now it has printed C. So there's C there at the beginning, there's C then hard at Ubuntu. If you notice that there it's just hard at Ubuntu, but then in this case there's C followed by hard at Ubuntu. So it hasn't printed a new line. So if you want to print a new line, whenever you want to print a new line, you specify using the new line character. Now, how do you get to use put? So put allows you to print more than one character onto the console. So let's just say this is the puts function. Now, the good part about puts is that you do not need to put a new line character. Put automatically puts the new line character for you. So let us just save this file. Then we are again going to compile it. So gcc then main.c. So now that we've compiled it, I didn't specify an output file, and so it's still a.out. So a.out, and so it's now saying this is the put function. So if you've noticed, put has already put a new line character for us, and so it has just printed this. Then it has also now printed the new line character, and so hard at Ubuntu has come on a new line. Now, how do you get to use printf? So printf, just as it says printf. So F probably stands for formatted. So printf helps you to print formatted output. So let me now uncomment this. So we have my var, which holds the variable, the value 98. So now how can we get printf to print this my var character, this my var value? So you can now say printf. Then coming back to the format specifiers now. So let's just say the value of my var is, then we can just do that. Then now coming back to the format specifiers, if you guys remember what we're doing. So we talked of format specifiers, and some of them were, let me just look at them. So the different format specifiers that we had are these here. So you have int, which is %d. So whenever you want to print an integer, you use the format specifier %d. So now that we've known the format specifier to use, let us now use that in the C file that we've made. So in this C file, I'm going to specify and say I want %d because I'm going to print an int. So after you've done that, you now put a comma, then you now specify the variable name, which is my var. Then we are going to save this, and again we'll compile using GCC, because GCC main.c. And so now that it has been compiled, I didn't specify the output file, so it's still a.out. So it will now say the value of my var is 98. Now again, if you see, printf doesn't put the new line character for us, so it needs to put it yourself. So you need to add the new line character yourself. So we are going to say %d, then we are going to specify and put a new line character there so that we get some nice output to the console. So we'll say gcc main.c, then I'm just going to execute the file, the executable file again, and now it's saying the value of my var is 98. So now what if you want to output different variables onto the console? So let's again go back to this. Then let me declare another variable. So I'm going to say this is, I'm just going to call it var. Then I'm going to say var is equal to 56. Now what if I want to print both var and my var onto the console? So you can say this, then we'll specify, so new line, so this is a new line. So the value of my var is that, then I'll say new line, then the value of var is, then I'm again going to specify because var is also an integer. So I'm going to use the %d format specifier. So I'm going to say %d, then I need a new line, so I'm going to specify and say new line character. Then I'm going to add another comma, then I'm going to add var after my var. So the way that these follow each other is the same way that they are going to be replaced in these format specifiers. So the first format specifier is going to be replaced by my var. The second format specifier is going to be replaced by the variable, the value that's in var. So let us save this, then see what's going to happen. So I'm going to compile the file again. I didn't specify any output file, so it's still a.out. So it's now saying the value of my var is 98. The value of var is 56. So this is how you can get to use the functions put, print car, as well as printf. Now, how can you use the function scanf? So the way in which you can use that function, so I'm just going to remove these for now. So I'm just going to declare these variables. Of course, if you want, here I declared both variables using one data type, then just said my var, then comma, then var, because it's the same data type. But if you want, you can actually say that, then you simply specify to say that this is going to be int. So int my var, like that. So you can also declare them like that if you want to. but then I just like declaring them on one line if it's the same data type. So now that we have declared these two variables, we can now use the scanf function to get input from the console instead of just using input from the program itself. So now how do we get to do that? So first of all, we need to tell the user to say that they need to input some to input some numbers into the console as arguments. So I'm going to use printf. I'm going to use printf, then I'll tell the user to say input value for my var. I'm not going to put the new line because I want the prompt to come just here. Just after this output input value for my var, then I want the prompt to come just there. Of course, I would have used puts, but then puts is going to automatically add a new line. So because I want the prompt to come just after this line, I have used printf. So I say printf, then input value for my var. Then I'm now going to use scanf. So scanf, then again use the same format specifier. So the format specifier for an int is %d. So I'm going to say comma, then I'm going to put an and. So and shows that it's more like you get the memory location itself. So and is saying I've passed the memory location of my var as an argument. So whenever you want to use scanf, you use and then the variable name. So %d, then my var. So this is now going to prompt to say that you need to add that. So after this, I now want to say printf again. Then I'll say input value for var. Again, I want the prompt to come just there at the end. So again, I'm going to say scanf. And because it's an int, I'm just going to say %d. Then I'm going to pass the memory location of var as an argument. So var, then after all this, I want to print the output to the console. So I'll say the value of my var is, so I'm going to use %d for the value of my var, then new line, then I'm going to say the value of var is, then I'm again going to use %d because it's an integer, so %d, then new line, then comma. So the first format specifier there, I want it to be replaced by my var. So I'm going to say my var, then I'll say comma, then the second format specifier, which is this one here, I want it to be replaced by var. So let us now see how our program is going to run. So I'll say gcc main.c. Then let us now execute the program. So I haven't specified any output file, and so it's still a.out. And so it's now prompting me to say input value for my var, and so I'm going to put 23, then input value for var, and I'm going to put 45 for this one. Then it will now tell me to say that the value of my var is 23, then the value of var is 45. So this is how you can use all the different functions, which is putchar, puts, printf, scanf, as well as puts. Now, for those different data types that we talked about, let us again say vi. Okay, let us just make another executable. Let us just make another program. So I'm going to say this is going to be vi size.c. So input, I'm just going to include the library. Just going to include the library stdio.h. So you now add your comments there. Commenting is really important, guys. Don't be forgetting that. So I'm going to say main, and I'm going to say this program prints the sizes of some data type. Then I'm now going to close the comments. Then I'm going to say int. So int main Then since I'm not going to pass anything as arguments to the script, so I'm just going to put void there. Then I'll say return 0. And so now, how do we get to see the different data types, the sizes of the different data types that we have? So there are two ways. If you want, you can actually declare a variable. So let's just declare it as var. So int var, then we are going to print. So we'll say printf, then we'll say the size of an int on my PC is, then you can now put the format specifier, which is LD for long. So if you guys again remember, for long it's usually 8 bytes, which is the format specifier is LD. So I'm going to use LD as a format specifier in this case, and so now I can put that. Then the function that I'm going to use is size of. So I'll say size of. Then if I want, I can pass this character, this variable as an argument to size of. So size of var, and it's going to print the size of an int. So let me just do that. Then I'll say GCC, then I'll say size of size.c. Then I'll now execute, because it's going to make one executable, which is a.out. I didn't specify the output file. So now if I run a.out, it's now the size of an int on my PC is 4. So this 4 is in bytes. So the size of an int on my PC is 4 bytes. So if I wanted, I could have said, so let me just add a new line character there, that the output would be nice. So if I wanted, I could have said int instead of var. So I could have simply said int like that. I'm just going to remove that. So the size of an int on my PC is size of int, and this will give you the size of an int. So I'll just say GCC, then size.c, then I can now print, so a.out, and so it will now tell me to say that the size of an int on my PC is 4. We can do the same thing for different sizes. So for example, for sizes like for the character data type, so let us check for character. So we can say the size of a float, or maybe we can check for a float. The size of a float on my PC is, so you now specify and say size of, then you specify that you want float, and so it'll give you the size of a float on this machine, and so it's going to be so GCC that, then I'll now compile, and it's now saying the size of an int on my PC is 4, and the size of a float on my PC is also 4. Now, what of a double? So for a double, I'm going to see what the size is. It's probably going to be 8. So let me just clear that. So GCC size.c, and I'm going to execute this. And so for a double, the size of a double on my PC is 8 bytes. So the size of an int is 4. The size of a double on my PC is 8 bytes. So this is how you can get to check the different the sizes of the different data types that you have on your machine. Now the next thing is, how can you compile these? How can you compile a C file from a script? So to start with, what is a script? Well, this is a program that contains a sequence of instructions or commands that can be executed without being compiled. So to comment in a script, you use hash, then the first line of your script always has to be the shebang. So let me just make the script. So I'll call this vi my script. So I'll say vi my script. And so the first line that you should have, the first line. Now don't make the mistake of putting this line anywhere else on your script, in your script. It has to be the first line of your script. So I'm going to say that, then I'll say that. Then if I want, I can use bin.bash, but then I like using USR to make my script portable. So USR/bin. So I'm going to say env environment, and I'm going to say bash. So to comment in a script, you use hash. So you use hash, then you comment. So we'll say this script compiles C files. So from here, the same commands that we're running on the console are the same commands that we are going to run even here. So let's say we want to compile the same size.c file, the one that prints the different sizes, the size for int as well as the size for double. And then we want to redirect the output into another executable file. So we are going to name our executable file. So we're going to say gcc. Then we are now, oh yeah, we forgot one thing. We need a variable that's going to help us so that we use the same variable in this script of ours. So to get a variable, we are going to say export. So we'll say, I'll call this variable of mine nice. So it's a nice variable. So I'll say nice is equal to, then I'm going to equate it to size. So size.c. So this variable of mine, nice, is holding size.c. So if I was to echo, echo nice, it should print size.c. So my variable nice is holding size.c, which is our which is our source code, the file that's holding our source code. Now the reason why I've used export is because with export, at least we'll be able to use the variable in child processes. So let me now go back to my script, then I'll use this same variable called nice, and it's the one that I'm going to use to compile whatever code I have. So let me go back via my script, and so from here, I'll now say gcc, then I'll now say this. So my variable nice is holding that same executable, that same source code. So gcc, so in place of nice, just imagine that there's now size.c. So gcc that, then I'm going to output this to a different file that I'm going to say script, maybe let me just say script executable, even though the name is too long. I'm just going to call it script executable. So when we compile, it's going to make this executable file called script executable. So let me just save that, then quit. Now this script of ours has to be executable. So how do you make something executable? So you say change mode, u plus x, then you say my script. So this is going to change that into an executable file. Then I can now run my script. So let's check again. So I want you guys to follow along. So if you check, there are only these files, the size, my script, main.c, main, as well as a.out. Now what happens when I execute my script? When I execute my script and do ls, it has now brought a script executable. So this script executable is executable which has come as a result of the compiled source code of size.c, which was held in the variable nice. So now let's now execute this one, which is script. So script executable, and it has the same output as a.out. So if I run a.out, it's the same output for both. So we have a.out, main.c, then that. So this is how you get to write your script and compile your program from the script. Now, what if I wanted to pass some arguments or some flags to my script? So I'm going to say assembly code. So now for assembly code, you guys remember it's supposed to be capital letter S. So GCC, the flag is capital letter S. Then nice. Then I want to output this into a file called assembly code. So this flag S is going to compile this size.c into assembly code. Now assembly code is a how can I put this? So assembly code generates is code that's more low level. It's more like a low level representation of the source code. So your source code, the code that we wrote in there, so everything that we wrote in size.c, this assembly code is going to be like a low level representation of that same code. So we're going to output that low-level representation into a file called assembly code. Let me just save that. Then I'm going to compile the script again. So let me just do ls so that you guys see the files that are here. The only files are these, my script and all that. Then I'm now going to execute my script. Then, so now that I've executed the script, it has now brought where is that one? Assembly code. So it has now brought assembly code, which is this one here. So if I want to see whatever is in there, I can use cat if I want. So assembly code, so cat assembly code, and this is what it has brought. So let me maybe use vi. So vi assembly code. So this is what's in the file assembly code. So this is the assembly code of the file size.c. It has even brought there. It's saying file, then the file is size.c. So whenever you want to execute an executable file, you first of all start with dot, then a forward slash. So dot forward slash, then you now type in your executable name. So if you want to be a bit quicker, you can be using the tab key for auto completion. So if I have an executable code, my script, I can simply type my, then I press the tab key and it's going to finish everything off for me. So like that. So that's how you get to execute executable files. So thank you guys for watching this video. I know it has been long, but I hope you've picked one or two things. So please, if you're new to the channel, don't forget to subscribe, like the video, and especially commenting so that I know what you guys think about the video.